Okay, unit 3.2, and in this unit we're going to learn about how to use the theorems of perpendicular lines. Let's start with two theorems here. Theorem 3.1, all right angles are congruent. So what this is saying is that if this angle here, look at this angle A, that's 90 degrees, and angle B is also 90 degrees. And if that's the case, then we say angle A and angle B, oops, sorry about that, and angle B are congruent, okay? And second theorem, 3.2, if two lines are perpendicular, so if, in our case, if M is perpendicular to N, then they intersect to form four right angles. So meaning the angle 1 is 90 degrees, angle 2 is 90 degrees, and angle 3 is also 90 degrees, and angle 4 is also 90 degrees. They are all right angles when the two lines are perpendicular. So let's see how we can use this. In the diagram, R is perpendicular to S, and line R is also perpendicular to line T. Determine whether enough information is given to conclude that the statement is true or not. So let's look at angle 3 and angle 5. Angle 3 and angle 5 are both right angle. So therefore, by theorem 3.1, they are congruent. Therefore, this is a correct statement, and we said that we proved it by theorem 3.1. Right angles are all congruent. Now, number 2, angle 4 and angle 5, are they congruent? Angle 4, notice that it's here. It doesn't tell us. It doesn't tell us angle 4 is congruent or not. So what can we do about that? Now, we know line R and line T are perpendicular. Line T is this one, line R is there. They're both perpendicular. So by theorem 3.2, angle 4 is 90 degrees. Is a right angle, and this is theorem 3.2. We know that one. And because of angle 3.1 says that all right angles are congruent, therefore angle 4 and angle 5 are also congruent. We can draw that conclusion. So in this case, we used 3.2 first, and we used 3.1 next. Okay? Now, the last one, let me erase these ugly handwriting. The last one, angle 2 and angle 3 are congruent. Do we have enough information about that? Let's take a look. Angle 2 is at the intersection of line R and line U. Notice that our problem does not mention anything about whether these two lines are perpendicular or not, and our diagram does not have any right angles. So even though they look like they're perpendicular to each other, it may be 89.9999 degrees, but it's not 90 degrees, and it may not be perpendicular. So therefore, I say that we don't have enough information to draw that conclusion. So that's how we use 3.1 and 3.2. Finish this checkpoint and we'll check your note in class. Okay, let's move on to theorem 3.3. It says that if two lines intersect to form adjacent congruent angles, adjacent congruent angles are the key words, then the lines are perpendicular. So let's take a look. I've got two lines here, line DB and line AC. I should have my arrows there. Okay, these two lines intersect, and then they form four angles here. 1, 2, 3, 4. I did not mention, I did not label 3 and 4. Let me do a better job with that. That's 3 and angle, oops, sorry about that. That's angle 4. And now, so if the two lines intersect and they form four adjacent congruent angles, then that means these four lines, that means each of these four angles is 90 degrees, is a right angle, and of course the lines would be perpendicular to each other. So in this case we say line AC and line BD would be perpendicular to each other. So that's theorem 3.3. Theorem 3.4 says if two lines of adjacent acute angles, notice that angles 3 and 4, 3 is here, 4 is here. These two angles right here. 3 is here, 4 is here. They're both acute angles, and when you put them together, they're adjacent together. And if the two lines, meaning EF and EH, are perpendicular, then angle 3 and angle 4, if you add these two angles together, they should be complementary, meaning they should be 90 degrees. That's a theorem with that in class. Here's an example. Let's see how we can use theorem 3.3 and 3.2. It says in the helicopter at the right are angle AXB, which is this angle here, and angle CXB, which is this angle that I just marked with a blue ink. Are they right angles? Are they 90 degrees? So we know by theorem 3.3 says that if AC, which is this line here, and BD intersect to form adjacent congruent angles, meaning these four angles are adjacent and they're congruent to each other, and now we know AC, line AC and line BD would be perpendicular to each other. And then if we use theorem 3.2, then we would know that because they are perpendicular to each other, if AC and BD are perpendicular to each other, then angle AXB and angle CXB, they both are right angles. They are both right angles. I should probably do a better job and write out English before your English teachers get mad at me. So angle AXB and angle CXB are right angles if these two lines are perpendicular to each other. Okay? This one, you will probably breathe a sigh of relief. It's geometry, but it actually has a little bit more algebra into it. It says that in this diagram on the right, EF, which is right here, EF and EH are perpendicular. Aha! What does that remind us of? Theorem 3.4 right here. If they are perpendicular to each other and these two angles are acute angles, meaning they're less than 90 degrees. So angle GEH is 30 degrees right here. I should use a different color. This red part, this angle here is 30 degrees, and the other part is 6y degrees. And we know because they are complementary, if we add them two together, they should be both 90 degrees. And then if you solve that equation, you will arrive at the conclusion that the value of y is 10, which makes angle FEG 60 degrees in this diagram. Okay, so that's how we use algebra with perpendicular lines to calculate the degrees of a certain angle. There are a couple of checkpoint problems. Please press pause, finish them in your packet, and we will continue the discussion in class. Thank you, everybody.